All right, 7.5, the last of the chapter 7 topics. We're still dealing with trig functions in kind of an algebraic point of view. But what we're going to be doing here is solving equations. In the previous video, we've been simplifying expressions or evaluating expressions, but we haven't been solving equations, which is the topic for 7.5. It turns out there's lots of little things I have to point out when we're solving equations with trig functions. So what I'm going to do is I'm going to split this section up into two different videos. I'm going to deal with some more complex equations in the next video. In this video, the equations themselves will be pretty simple, but that doesn't necessarily make the problems easy because there's lots of little things to be careful of. So let me start with an example. Suppose you were told that 2 times the sine of x minus 1 equals 0, and you were asked to solve this equation. Well, if you didn't have any guidance or anything else, maybe you would just think to add 1 to both sides of the equation and get that 2 sine of x equals 1, and then divide both sides of the equation by 2 and get that sine of x equals 1/2. And then think about, let's see, sine of x equals 1/2. When does that happen? I guess that happens when x equals pi over 6, right? Right? Well, yes and no. It's true that the sine of pi over 6 is equal to 1/2. So pi over 6 is a solution to this equation. However, it's not the only solution to this equation. There's lots of different angles so that when you take the sine of that angle, gives you 1/2 as the answer. Pi over 6 is just one of them. Here's my poorly drawn unit circle. The sine is the y-coordinate on the unit circle, so 1/2 is roughly here. There's an angle over here, which is the pi over 6 that I just referred to. But there's another one over here in the second quadrant. And you're like, yeah, okay, fine. What's that, 5 pi over 6? Cool, so there's two answers. Yes, but we can refer to these points differently, right? I could refer to this as negative 7 pi over 6, for example, or instead of pi over 6, I could take a lap around my unit circle and then go another pi over 6. So this is also 13 pi over 6. There's actually infinitely many angles that are coterminal with this point. So there's infinitely many solutions to this equation. So that leaves us with some options. You can either describe those infinitely many solutions. You can say it's pi over 6 plus or minus any number of 2 pi's that I want, and it's 5 pi over 6 plus or minus any number of 2 pi's that I want. You can do all that, but what I'm going to do in our class is I'm always going to limit the range that your answers can lie in. So I'm going to say that your angle x here has to be between 0 and 2 pi. These are the standard bounds that I'm going to use in this class, although you'll see on the homework, this isn't the only way they could restrict your answers. It's just the most common, so it's the one that I'm always going to use. At any rate, with this question, the way that it's written, there's exactly two solutions, and they're pi over 6 and 5 pi over 6. Here's another equation. Now it's tangent of x plus 1 equals 0 that we want to solve. And you're like, this is even easier than the last one. Just subtract 1 from both sides of the equation, and I get that the tangent of x equals negative 1. So all I got to do is think about my unit circle and try to figure out what angles correspond with the tangent value of negative 1. Well, let's see, tangent is the y-coordinate divided by the x-coordinate, and in order to make a fraction equal to 1, the top has to be the same as the bottom. So in order for the fraction to be equal to negative 1, I want the top and the bottom to be the same in terms of absolute value, but 1 to be negative, 1 to be positive. What I'm talking about is the point that's over here, where x is negative root 2 over 2 and y is root 2 over 2, and the point down here, where x is positive root 2 over 2 and y is negative root 2 over 2. But be careful. Here, my values of x were specified to only lie within 0 and pi. So the only solution in this range from 0 to pi is this one at 3 pi over 4. It's true that the tangent of 7 pi over 4 plus 1 also equals 0, but since 7 pi over 4 is not within this restricted range, it would not be a solution in this case. And you're like, hey, wait a minute ago you told me you're typically going to restrict things to lying between 0 and 2 pi. Why'd you make it 0 and pi here? Well, because the period of tangent is equal to pi, sometimes when you see trig equations where tangent is the only trig function going on, instead of restricting things to 0 to 2 pi, they'll restrict them to 0 to pi, because any solution I get here, I know that if I add pi to this answer, I'll get another solution, so I don't even need to bother specifying it. Wait, that got really confusing. Okay, all I'm saying is make sure you look at the range that I give you and only pick the angles that are in that range. And typically, that range will be from 0 to 2 pi. However, if you have an equation that only involves tangents, sometimes that range will be between 0 and pi. And when that's the case, just tell me 3 pi over 4. By the way, if this is the final exam and you're like 3 pi over 4 and 7 pi over 4, you know what I'm doing? I'm crossing out that 7 pi over 4 and being like, whatever, good enough, full credit. You knew the right idea. You just didn't look at this restriction. It would be a little bit bigger of a deal if up here you only told me pi over 6 and not 5 pi over 6. I want you to see that there's at least these two solutions here. But down here, if you told me more solutions than there actually are because you didn't restrict them appropriately, I'm not super worried about that. Another example, if you look at 3 here, it looks really similar to 1. Red and blue, about the same. I bet they're about the same in difficulty. Turns out not at all. blue is going to be considerably more difficult than red. In fact, I'm going to have to do two examples kind of like blue to try to make this make sense, and then I'll end this video. For blue, what's going on is my equation is 3 times the sine of x minus 1 equals 0 instead of 2 times the sine of x minus 1 equals 0. So similar, how much different can it be? Well, let's see. Let's add 1 to both sides, and we get 3 times the sine of x equals 1. Then let's divide both sides by 3 and get the sine of x equals 1/3. Up here, I had the sine of x equals 1/2, and all I had to do was think about my unit circle and come up with the two angles that I have memorized that have a y-coordinate of 1/2. Those are pi over 6 and 5 pi over 6. Down here, I'm looking for points on my unit circle where the y value equals 1/3. That's a problem. I don't have memorized any values on my unit circle where the y-coordinate equals 1/3. Right, if 1/2 is right here, 1/3 is, I don't know, maybe down here. So I'm talking about, I don't know, loosely speaking, the angle that terminates over here and the angle that terminates over here. This angle in blue and this angle in red. But what are those angles? I don't have memorized angles who have y values equal to 1/3 on my unit circle, but that's okay. We can solve this equation. Remember, our goal is to get the x all by itself. We weren't done at this stage when we said sine of x equals 1/2. We had to go one step further and figure out what x was equal to. We're not solving for sine of x. We're finding values of x that are solutions to these equations. So what I got to do is I got to get this x all by itself. How can I rewrite this as just x equals something? How about inverse functions? What if I used arc sine? If the sine of x equals 1/3, then maybe you're comfortable with me saying that the arc sine of 1/3 must be equal to x. These are equivalent statements, but this one, the x is all by itself, which was my goal. It was to solve for x. And you're like, wait, so I'm done now? X equals arc sine of 1/3? Well, almost. Remember, arc sine was really tricky. We had this thing where we had to restrict the domain of sine to define arc sine because sine was not 1-to-1. You're like, yeah, I kind of remember that from the inverse trig functions. I remember hating it and never really understanding it. Well, what you were supposed to get out of that is that the range of the arc sine function is from negative pi over 2 up to positive pi over 2. In other words, the right side of my unit circle. So when I say the arc sine of 1/3, I'm only referring to an angle on the right side of my unit circle so that the y-coordinate of that angle is equal to 1/3. I'm referring to this angle in blue right here with this answer. But there should be two answers. It's the answer in blue and the answer in red. How do we get the answer in red? Well, we can take advantage of some symmetry. The arc sine of 1/3, which again is this little angle right here, also shows up in my picture over on this side. So if I wanted to refer to the red angle, what I could do is go halfway around my circle, that's a distance of pi, and then back up by this little amount. Remember, this little amount is the arc sine of 1/3. What I'm saying is the angle in red I could think of as pi minus a little bit, that little bit being the arc sine of 1/3. There's two different solutions in this range from 0 to 2 pi for this equation, and they are the arc sine of 1/3 and pi minus the arc sine of 1/3. And for what it's worth, I really think you need to be an expert in a lot of different topics to be able to come up with both of them. These problems, where you end up with solutions that are not memorized values off your unit circle, are super hard. But the good news is I, your teacher, recognize that they're super hard, so I'm going to give you lots of practice with them, and I'm not going to ask them all that frequently. Let's do one more. This time my equation is 5 times the cosine of x plus 4 equals 0, and my range is again from 0 to 2 pi. It's worth pointing out that typically it'll be restricted from 0 to 2 pi, not including 2 pi. I put a less than or equal to sign here. It really doesn't matter because 2 pi itself isn't a solution here or here, so it makes no difference. But just in case you ever saw an equation where 2 pi itself was a solution, what I should do is rewrite these so that they're strictly less than 2 pi. At any rate, our equation, let's solve it. Solving the equation is pretty easy because, again, these are all the what I refer to as basic types of equations. All I got to do is subtract 4 from both sides of the equation and then divide by 5. So I get 5 times the cosine of x equals -4. So the cosine of x equals -4/5. This is where you kind of sigh and you're like, oh man, I wish this were one of the memorized values off my unit circle so I could just say what the angles are equal to and be done. It's not, so I'm going to have to end up using this arc sine or arc cosine in this case trick, which is going to be really annoying. Even worse, it'll turn out in 4 than it was in 3. My advice, draw the picture. The picture's your friend. The cosine of x equals -4/5. The cosine is the x coordinate on my unit circle. -4/5 is almost -1. -1's right here. So -4/5 is, I don't know, somewhere over here. So the angles I'm talking about are this guy here and this guy here. I want the angles to be between 0 and 2 pi, so I want to measure those guys in these directions. I got the red one and I got the green one. What am I going to do? Well, to get one of those, I can just solve this equation for x. So I can say if the cosine of x equals negative 4/5, then x is the arc cosine of negative 4/5. If you remember anything about arc cosine, its range is not restricted from negative pi over 2 to pi over 2, but instead from 0 to pi. Informally speaking, the top half of my unit circle here. So when I talk about the arc cosine of negative 4/5, what I'm talking about is this angle depicted in red. This is one of my two solutions. It's only one of the two solutions though. I also need this solution. How can I refer to this angle in green here? That's a little bit more challenging. There's a couple ways you can get there, but you might notice that the angle in red, if I measured it in the opposite direction, would leave me right here. If the angle in red here is the arc cosine of negative 4/5, the angle in blue is the negative of the arc cosine of negative 4/5. And you're like, oh, okay, so that's my answer? Nah, you don't want blue, you want green. Both blue and green leave you at the same point. Those are coterminal angles, but the angle you want has to be between 0 and 2 pi, and this is not between 0 and 2 pi. How do I know this is not between 0 and 2 pi? Because this is between 0 and pi. It has to be. This is some positive number in between 0 and pi. So when I negate that, it's some negative number in between negative pi and 0. That's not going to do. My answer has to be between 0 and 2 pi. What I can do to measure this green angle is think about making one full lap around the unit circle, which is 2 pi, and then going back by this amount. To go back by this amount, what I have to do is add this negative arc cosine of negative 4/5. What I'm saying is the angle in green, the second of your final answers to this question, will be 2 pi minus the arc cosine of negative 4/5. Think about it like I'm taking one full lap around the unit circle, and then I'm backing up by this red angle. Subtracting this red angle is the same as adding this blue angle, which is what gives me the angle in green that I wanted. That's really hard. I think I got to do one more of these. I know I said that was the last one. I think this is so hard it deserves one more example. I'm going to squeeze down here in green. It's going to look a lot like what we did in blue. We're looking for angles between 0 and 2 pi. Our equation instead of 3 sine of x minus 1 equals 0 is 3 sine of x plus 1 equals 0. So to get the sine of x by itself, subtract 1 from both sides of the equation, and you get 3 sine of x equals negative 1. And then divide both sides by 3, and you get sine of x equals negative 1/3. Time to draw a picture. The sine is the y-coordinate. The 2 points that have such a y-coordinate are this guy here and this guy here. I'll make one of them green and one of them blue. Sorry to any blue-green colorblind people. And then remember that my angles have to be between 0 and 2 pi. So I want to measure this blue angle like this, and I want to measure this green angle to make sure it's between 0 and 2 pi like this. That's going to be a problem. Why is that a problem? Because remember, the range of arc sine is from negative pi over 2 to pi over 2. From here, where we have the sine of x equals negative 1/3, you're probably thinking that x should be equal to the arc sine of 1/3. It turns out it won't be. I'm even going to write it. X equals arc sine of negative 1/3? Question mark. The answer is going to be no. Why is the answer no? Because arc sine is restricted to negative pi over 2 to pi over 2. So it's talking about the right-hand side of this unit circle. And you're like, yeah, this point's on the right-hand side of my unit circle. Right, but it's not between negative pi over 2 and positive pi over 2. This is measured in this direction, which will give us a number damn near 2 pi, well outside of this range. The arc sine of negative 1/3 is a negative number. It's the angle that is measured this way to leave us at this point. I know this doesn't look like a negative number, but this is a negative number so that it falls within this range. That's a problem. Our answers aren't supposed to be negative numbers. They're supposed to be between 0 and 2 pi. So what I have to do is use this angle in red to refer to the angles in green and the angles in blue. Let's do green first because that's easier. For green, if I took a full lap around the unit circle, that's 2 pi, I'd end up right here. But I don't want to go a full 2 pi. I want to go a little bit less than a full 2 pi so that I stay within this range from 0 to 2 pi and end up at this point. How much less? Well, whatever this angle is right here. Remember, this angle, the arc sine of negative 1/3, is a negative angle. So I'll take 2 pi and I'll add that negative angle. Adding a negative is the same as subtracting a positive, and that will leave me at this point. What I'm saying is that x is equal to 2 pi plus the arc sine of negative 1/3. That's the angle that's shown in green that falls in this range from 0 to 2 pi. What about the angle in blue? Well, for the angle in blue, I can go a distance of pi to get over here, and then I have to add on a little bit more. How much more? The amount extra that I'm adding on here is the same as the magnitude of this angle. But there's a problem. it's not just going to be pi plus the arc sine of negative 1/3, because again, the arc sine of negative 1/3 is a negative number. So if I took pi and I added this negative number to it, it's subtracting. It would leave me somewhere up here. I don't want to end up here. I want to end up down here. What I have to do is take pi, which gets me halfway around the circle, and then go a little bit further. The way I'll go a little bit further is I'll subtract this negative angle, because subtracting a negative is the same as adding a positive, which gets me a little bit further over to this point here. The more of these examples I do, the more I realize that these are insanely hard. Try your best to follow these examples so that you can get the points on the homework. And note that if you saw this on a test or something, I would either be super reasonable in grading them or I would make it extra credit.